So good morning, everyone. And if you have not said good morning, please type good morning in the chat window, so I know you are here. And we have 22 students. We have 21 students now. And good morning. Yeah, thanks. And so everyone can see my slides in full screen, right? Mm-hmm. Yes. Yeah. Thanks. Yeah. Thanks. Yeah. Thanks for the feedback. So this is our second week and our third lecture. And for this week, we will keep talking about the Matlab fundamentals, and we will go through the some fundamental knowledge about Matlab. And if you already know Matlab very well, and this you can think this as a review. And if you don't know Matlab, I feel like for this week, you can use these two lectures to quickly start the Matlab. And so let's start. And so today is January 24th and Tuesday. So first of all, I want to remind you that the quiz 1 and homework 0 is posted on my courses, and make sure you have access to them. The deadline is I think it's in 10 days when I posted it. And first of all, if you have not installed Matlab, please install it on your PC or on your laptop. And it's free, so it's kind of like a benefit as a student at RIT. So make sure you install it because you absolutely need it to finish your homework, your project. And so the second is, how is your homework? And we don't have any results yet, but I believe most of you should get things in okay. So did you have a chance to take a look at your homework? And if you have done that, please type yes in the chat window. If you have not done that, please type no. Yes, yes, good, nice. That's good. Thanks, everyone. And so the homework 0 is just for you to warm up, and it's just some very fundamental knowledge about the. Would anyone like to exchange headshots for the homework? That's a good question from Matthew. Yeah, and so I think that assignment is to help you to at least talk to at least one student in the same lecture or the same class, because this is an online class. So the purpose to exchange the headshots is to make sure you have someone to reach out and to discuss something for this lecture. Yeah, thanks for the question, Matthew. We have another Matthew, okay? So here's another question. Are our pictures supposed to be taken horizontally so we resize it? We don't look skewed when we resize. For homework 0, it's fine. So it doesn't matter as long as you have an image, you can resize it. That's all. So don't have to worry about the skew issue for now. But if you want to present a perfect picture, of course, and you can decide what kind of picture you want to take. Yeah. So any other question about the homework? Or okay, we have a question from Michael. Should we start the quiz now, or should we wait until after Thursday's lecture? I think you can start it now. The quiz is not to challenge you, and if you notice that you have 3 chances to take the quiz. For example, we'll take it for the first time. If you don't if you didn't finish all the questions correctly, you have a second chance or a third chance, even a third chance, and to improve your score. So I think you can take the quiz now, and you can also wait until the deadline. Is totally up to you. But I think all the questions shown in the first quiz has been discussed in our first week. Yeah, no problem. And also, I want to remind you again that you have 3 chances to take it. It's 3 shots. Any other questions? Good. Great. So if you have any questions regarding the homework or even in the future about the projects, don't hesitate to contact me. And because my teaching philosophy is that I believe that you can learn the best when you are actively involved in the learning process, and which is why I encourage you to keep asking questions and participate in our class discussion. Uh, oh, we have another question, Vedika. Have the Zoom recordings been uploaded? I can't say them. Not yet. So I'm gonna upload it in somewhere, and I'll share you the link. And also, please don't distribute the videos to the other students who didn't enroll the class. And let's only keep it for us. Okay. I'm gonna share a link for you, so no worries about it. So any other questions? Great. Okay, we have another question from Matthew. How do we set up our directory? What do you mean? Oh, you mean the homework? Um, I think there's enough. I think there are very detailed instructions for your directory. You just create a folder and with your name. I remember. So it will be the homework name, the homework's name, your last name, your first name. I made the function, but it gives me an error when I put the cd edit. Interesting. Um, uh, Maybe we can look at it. Yeah, sure, no problem. We can discuss that later after the class or mhm. Good. So yeah, so I think that is so like I mentioned, I think it's important that to create a safe space, where all students can feel comfortable asking questions and expressing yourself, without fear or judgment, okay? And also, as I mentioned, for the projects, I have not finalized the project yet, but it will involve analyzing the plans, and you will apply everything you learned in this class. For example, the image processing and morphological processing, object detection or k-means clustering, and finally by using the artificial neural networks or convolutional neural networks to classify the plans. And at the end, I have not finalized it, but it will be maybe you will give for example, for your project group, maybe you will give like a 15 minutes presentation in one of our lectures. And of course, there will be a project report. And you can expect more information in our following lectures. So any questions regarding the projects? And also, by the way, there will only be one project. Okay. You can finish the project independently, or you can have a project group. And for the group members, no more than 3 students, including you, no more than 3 students. All right, so if no more questions, let's start our today's lecture. And first of all, let's review what we learned in last week. So some key items is I want to remind you is that Matlab has block comments, like we mentioned in our last lecture, is the percent curly brace, and followed by the percent sign, and with the right curly brace. And everything in this block will be commented. And for Matlab, and maybe some of you are interested in this fact, is, the Matlab was programmed by C and C++. And also we discussed the control flow statements. We covered if else, else if, and else. We covered the for loop, while loop. And also we discussed a few data types. For example, like the and integer 8, the float, and the string. We covered a few functions, the RGB to gray function, the IAMShow, IAMRead, and IAMResize. And I believe you will use them in your homework. And also, when I mentioned for example, the RGB to gray function, you may wonder how it works, right? Because we have an RGB image which has 3 channels. And in fact, in the Matlab, it actually is actually a weight for different channels, and the function is shown here. And you can find more details in the bottom link to show you how this algorithm can convert the RGB to grayscale in Matlab. And this is for your information, and you don't have to. If you're interested in the algorithm, you can dig more about this function. And also we mentioned the IAMResize function, which uses a bicubic interpolation by default. And of course, you can try some other interpolation method like the nearest neighbors or some other methods. So for today's lecture, we will cover the digital images and how to read and display and rewrite images. And we will discuss the data classes in Matlab, and also the image types and how to convert between the different image types. And in the end, I will cover the interactive input and output, and also show you how to plot an image in the Matlab. So sounds good?
Yes, perfect.
Yeah, thanks. So first of all, let's talk about the digital images. So in Matlab, an image may be defined as 2-dimensional functions, for example, f, x, y. So where x and y are spatial or plane coordinates, and the amplitude of any pair of coordinates x, y is called the intensity of the image at that point. And the term, so we mentioned the grayscale or RGB. The term gray level is used often to refer to the intensity of the monochrome image. Also, in common, it's called a grayscale image. And color images are formed by a combination of individual images. For example, like we mentioned, the RGB color system, is a color image consists of 3 individual monochrome images, which are referred as the red, the green, and the blue primary images. And an image might be continuous with XY coordinate and also the intensity. So converting such an image to digital form requires that coordinates and the amplitude be digitized. And digitizing the coordinates is called sampling. So digitizing the amplitude is called quantization. So that's a difference between the sampling and quantization. So let's say it one more time. Digitizing the coordinates is called sampling. Digitizing the amplitude is called quantization. So therefore, when x and y and the amplitude values are all finite, these are discrete quantities, we call the image a digital image. So the elements of a digital image are called pixels. So those are some concepts that you want to remember. And also most images you know are a color which usually consist 3 different channels, the red, green, and blue.
Professor, question.
Oh, yeah, go ahead.
Professor, okay, I just wanted to know, digitalizing the amplitude is known as, you told me something. Coordinates is sampling, amplitude is?
If you're digitizing the amplitude, it's called quantization.
Okay. Thanks, Professor.
Yeah, no problem. Any other question?
Can you just say what amplitude means again in the context of a picture?
Yeah, sure. Amplitude means so for example, like I mentioned here, amplitude is just the pixel value, yeah.
Like the pixel value from like 0 to 225 or 255?
For unsigned integer 8, it's just 0 to 255, yeah.
So like the amplitude refers to like, if it has like low amplitude, it's like a white image, and if it's got high amplitude, it's black.
I think if it's a low value, is black. So for 255, for a high pixel value is white. Yeah. Makes sense?
Yep.
So any other question regarding the digital image? Great. So here is an image coordinate system. So the result of sampling and quantization is usually a matrix of real numbers. And we use 2 principal ways in the book. In our textbook, there are 2 principal ways to represent the digital images. So assume that an image fxy is sampled uniformly so that the resulting image has m rows and n columns. So we see that this matrix is m by n. So you can see that here we have a matrix for the columns is m, and for the rows is m, and for the column is n columns. So in this case, the size of this it will be m by n. So the coordinate convention used in the image processing toolbox is a little bit different. But first, instead of using the xy, it usually uses, if you see the bottom of our slide, it uses the RC to, the notation is RC to indicate rows and columns. And the order of the coordinate is the same as above. So in the sense that the first element of the coordinate tuple is the rows, and the second is the column. Refers to a row, and the second to a column. So the other difference is that the origin of the coordinate system for RC at RC is 1, 1. So if you pay attention to the top left, our origin starts at 1, 1, not 0, 0. So therefore, for the R, it ranges from 1 to m. For the C, the column, it ranges from 1 to n in integer increments. So in some cases, Matlab and Toolbox employ another coordinate convention called spatial coordinates. So for example, for the spatial coordinates, is something like this one. So for the x-axis is this is axis, this is y. So that's a common coordinate system that uses x to refer to the columns and y to refer to the rows, and x is the columns. So this is opposite of our use of variables x and y, and and it can be a source of confusion because you will encounter it in Toolbox and Matlab documentation. And be aware that Matlab itself is not always consistent in the meaning it assigns to a tuple A and B. So sometimes you can expect the X, Y, the spatial coordinate systems. And sometimes in Matlab, A and B might be an image coordinate system. And it's not always consistent in Matlab. So that's why you want to pay attention when you use this during your programming. And Matlab assumes that the first element refers to the rows and the second refers to the column. So in other contexts, for example, when you plot a function, the reverse is true. So, but no worries, we will generally mention it whenever whenever it occurs in our discussions. So any question for the image coordinate system? Okay, good. If no question, oh,
No, Professor.
okay, good. So next is the image as matrices. So in our world, in our MATLAB world, or in our computer vision world, the matrix is an array. A digital image can be represented as a MATLAB matrix. So is everything a matrix? Of course not, but for now, you can assume that everything is a matrix. Even a single scalar, for example, 1, you can think of it as a 1-by-1 matrix for now. And here in our slide is an example is M by N image array. So M is the rows and N is the columns. And of course, for the common matrix formats for our image types, there are many supported format in MATLAB, and the most common are like the GIF, the JPEG, or the PNG or TIF. Those are some common images, and which are supported by the IM-read and IM-read function in MATLAB. And you want to pay attention for, I think, if they didn't upgrade their system, in my courses system, and JPEG and PNG are the two best formats. So if you want to upload any image, make sure it's in a JPEG and .png mode format in my courses. And HEIF is not supported in my courses, if I remember it correctly. Which stands for the high efficiency image file format. Usually it's created by iPhone. So you want to pay attention when you upload images, make sure it's in a JPEG and PNG format. And of course, there are some other vector image formats, and the most common form is SVG. SVG stands for the scalable vector graphics. which is out of the scope of for this class. And but if you're interested, I believe we have another professor who teaches the computer vision. I think his name is Dr. Thomas Kinsman. He's teaching the CS 431. And I think he's working on elective course on computer controlled artwork, which use the vector formats a lot. So if you're interested in that part of work, so pay attention to his class. Yeah. So so let's see some detailed examples. So if you have installed Matlab, you can also open your Matlab. So when I show you the examples, you can try it in your Matlab. So the first thing I want to mention is the reading, displaying, and writing an image in Matlab. I think we covered a little bit in our last lecture. And if you want to read an image, you can use the IM read function. So here is the Pierce image sample. And to show your RGB image, you can use IM show functions. And in the homework, I remember I asked you the maximum image of the maximum size of the image. So I think some students also ask this question. I mean that the original size of your image. And to get the size of your image, you can use the size function for your input image, and then you can say for my image is 486 by 732. And the third means this is an RGB image which has 3 different channels, the red, green, and blue. And there is a very useful function called whose. Whose function will give you a little bit more information about the image. So you can see that by using the whose function in your prompt command window, it will show you the name, the size, the base, the class, and the attributes of your image. So that's kind of give you a few more information. So here's another example regarding the RGB image. So here is a sample image of a baby. And to show the different, for example, if we want to say the R channel, or we also want to display the image separately. So to do that, you can just use this format as here. So colon means that we will iterate through all the values in that dimension. So for this, you can think the first one is the rows, and the second is the columns, and the third is the channels we want to choose. For example, the first channel is red, the second is blue, and the third is green. Oh, my bad. The second is green. The third one is blue, RGB, yeah. And so when you display just one channel, it will just give us a grayscale image. So that's what it shows here. And that's the red, this is the green, this is blue. And we have a fourth image. You may wonder what this means, right? So to display this darker image, we use show functions. And here I choose the third channel. And so here is a quick question for you. So what does this mean 100, 200 means in this function? So does anyone know the answer? Row, column, any other feedbacks? Vedica, range, what kind of range? Does it lock the values to be in that range? image size, is it only show values in that range? That's almost there. So does show the values in that range, but how about the other values? What this function does?
Does it scale the values in that range?
Yeah, that's good answer. And so yeah, I think all of you got some points for this one. So what it does is that, as you mentioned, so someone mentioned it kill the pixel values. Actually, what it does is that for the values that are less than or equal to 100, it will display the as black. And for the pixel values that are greater than 200, it will just display white. So that's what it does. And for the values between 100 and 200, it will keep it as it is. So make sense?
Yes, Professor.
Yeah, thanks for the feedback. All right, so, and it's also called, I think in Matlab, it's also called the auto range syntax. It's called auto range syntax. So Matlab can do more than that. So if you use, here's another very helpful function called imfinfo. So by using this function, it will give you more detailed information regarding an image. So here we have a car, and by the imfinfo function, you can see that it will create the structure with many different fields. So you can see the file name and the format, the widths and heights, the bit depths. And of course, there are more information like resolution and for time reason, I will not go through this for you, but you can check after the class to see what all these attributes mean. So what I want to show you is another function, like how to write an image. So here we have two images here. On the right side is our original image. On the left is a reduced image by using the quality method. So when we write an image data, for example, when we read the image and we call it RGB, or you can call it F or something, any variable name, you can define that. So when we write an image data RGB to the file, we need to specify the file name. So we need to give it a file name. And here I choose some method called quality. And so for the quality method, is an integer between 0 and 100. So you see that here I use 1. So this value is ranges from 0 to 100. So the higher the number, the lower the degradation caused by the JPEG compression. So what it does here is a compression. You can see that after the reduction, our image resolution we have a very bad resolution for the left image. And to write this image and save it as a new one called reduced car, and we can just use this imret function here. So very straightforward, right? So any question for this function? And of course, there are many other methods, besides the quality. And in Matlab, you can just check the functions of the imret, just type help, imret or doc, imret, you can find much more information. All right, so if no question, we will go to our next slide. So image types. So in this class, we will mainly discuss 4 different types of image, which are grayscale image, a binary image, an RGB image, and indexed image. And a grayscale image is a data matrix, like we mentioned, whose values represent the monochrome intensities. We also call it the shades of gray. So when the elements of a grayscale image, for example, is a class of unsigned integer 8 or unsigned integer 16. So they have integer values in the range of 0 to 255. For example, for this one is 0 to 255. And for this one is from 0 to 65530, 35, if I remember. So which is how a computer works, this is just a 2 to the power 8, and this is just 2 to the power 16. And for the binary image, it has a very specific meaning in Matlab. So for binary image, it's a logical array of zeros and ones. So there are only 2 pixel values for the binary image, which is 0 and 1. And so an RGB image is just like 3 channels of image, and for index image usually has 2 components. So an integer data matrix X and a color map matrix map. And so for color map is usually X by 3 matrix of data type, usually is double and with values in the range from 0 to 1. And each row of the color map specified the red, green, and blue components of a single color. And the length of the map is usually equal to the number of colors it defines. So I'm going to show you an example in our next lecture. So for today, you don't have to worry about RGB image and index image. And today we just focus on grayscale and binary image. So that's all you need to know for today. So let's say an example to convert between the types. So for example, we have a F matrix, which is defined here, and we want to convert it to unsigned integer 8. And all it needs to do is to use the IM to unsigned. Oh, let me go through this first. So to convert the different image types, I listed some functions here. Those functions are something that we will commonly use. We will commonly use in our homework or for your programming. So I'll give you 30, maybe give you 30 seconds. Try to go through these functions first. All right, so let's continue. So here I'm trying to convert a matrix to the unsigned integer 8 data types. So you just use the IM to unsigned integer 8, and so the result will be a unsigned integer 8 matrix. So you may notice that we have a 0 here, right? So for this function, for the function IM to unsigned integer 8, it sets to 0 all values in the input that are less than 0. So if all the values that are less than 0, in the ancient integer 8, it will just be 0. And for all values that are greater than 1, if you see that we have 1.5 here, so all the values greater than 1 will be set to 255. And rounding the results of the multiplication to the nearest integer and next is the logical functions. So for the logical, it will just convert your float to a logical array. And so this is a classic class logical. The function logical converts an input array to a logical array. So in the process, non-zero elements in the input are converted to ones, and 0 values will be converted to 0 values will be converted to zeros. So you see that for the logical G, and the 0 will be converted to 0, and all the other values will be converted to ones. Okay, good. And an alternative to function logical that often is more useful is to use a relational operator, such as the operator, greater. So if you, for example, with the threshold value, for example, if we have something, we have a matrix, and we have a threshold. By using the operator, the greater operator, we can also create a logical array in this format. So it's similar that it will produce this logical array, containing wherever the element of ones are greater than t, or if the f for the values in f is not greater than the threshold, it will set up zeros. And so here we have another function which is called im binarize. So the toolbox function im binarize performs the thresholding operation, handling the input image class automatically, which also create a logical array for us. So let's say another example here. So imagine we have a matrix that is F. F is a 2x2 matrix, is 0, 1, 160, and 200. So when we use the rm2 ancient integer 8 function, we got something like this. So what happened, right? Is this something we want? It seems that we got something weird, right? So when we use the after we applied this function, you see the last two numbers, not what we expected, right? So we got some 255, 255. Why 160 and 200 becomes 255? Well, the reason for this result is that for the function rm to ancient integer 8, by default, it converts for any double zero. By default, it will convert to 0 any double zero, a negative value. And 251, any double number that is greater than or equal to 1. So that means for a double value that are greater than 1, for all those three numbers, it will convert them to 255. So, and anything, for example, any number of class double between 0 and 1, so it will just convert proportionally on a scale from 0 to 255 when we apply this function. So that's something you want to pay attention when you do the data when you do the data types conversion. So I would suggest you try a few examples in MATLAB first, so make sure you know what they're doing before you apply it to a large scale image. So any question for these two functions? I think is very okay, good. Great. So let's go to the next one. So next thing I want to mention is the plotting function. So in MATLAB, and here's a very simple example by using the plot. And in 2D for two-dimensional plot, it's just the plot function. And here we use a line space function to create some sampling points. And the range is from -2 pi to +2 pi. And 50 means I have 50 samplings in the x-axis. And so here I want to plot a sine waveform. So for the y1, just use the figure and with a comma, and then use plot xy. And if you don't add any other methods or arguments, it will just, by default, it will just display this this sine waveform for you. And in MATLAB, so this is a very important thing. You will want to remember these things for this table. So in the table 2.17 in the textbook, these are the line specification attributes. And for example, to create, there are different, for example, for the line styles, there are solid, dotted, dashed lines. And those are the symbols you want to use. And for the marker types, you can have a point, you can plot point, circle, cross, plus, asterisk, and square, and diamond. And for the color, there are blue, green, red, cyan, magenta, yellow, black, and white. And to apply these attributes in the plot function, all you need to do is to type them after your x and y variables. For example, here we have a red RO. So R means red and O means circles. And you can initiate, in MATLAB, you can initiate the hold state, which means hold on. And then you can plot another one, which is another type, which is K and dash. So this means that we want to plot the black dashed lines. And for the first one is the red circles. And to terminate the hold statement, you can just use hold off. So that's the image that will plot for us. And here is another example. And if you want to plot for example, the sine waveform and the cosine waveform together, you can just plot them by in the right in this. Oh, I think another thing I want to comment is that the order doesn't matter for the attributes. So if, for example, here and for this one, if you change the order, it will still create the same image for you. And for example, if you want to plot more functions, you can, for example, xy1 and xy2, you can just type them in order. And for the first one, it's just a green solid line. And the second one is for our sine waveform is a green solid line. You can see that in the figure. And for the cosine function is a magenta dashed line. So you can see the second one. This is the sine. This is the sine function, and this is the cosine function. Yeah. So why the reason I show you this one is I want to show you that we can create the same combined plot using just a single command. So you can type them in, for example, in the previous function, you can type in this slide, you can type them separately, or you can type them in a single command. And one more. So for some other attributes we commonly use is the line-wise attribute. So which will change the lines wise. And you can see that for the first one, we use both, it's like a 2, the size is 2, the second one is 0.5. So far we have specified some graph properties, for example, like the line-wise, and accepted the default values for others. For example, like the axis values and the locations of the tick marks. And so I wish after the class, you can try to, play with the code and try to figure out what's more, right? So besides this, what else you can find? So generally, access and modification of graph object properties is achieved using the dot notation, just like very similar to the structures. For example, here it's just to show you how to add the title and the X label and Y labels. So by these functions, you can create the XY labels here and also the titles. So the next is a 3D plots. And so the 3D plots in which we are interested in this class are plots of functions of the form for example, if we have a function that is a function of X and Y in this format. So X and Y are the plane coordinates, and Z is plotted as the height. So in the following discussion, we will work with 2 types of 3D plots, the mesh and the surface plots. So these 2 types of plots are the backbone of Matlab 3D plotting, and a clear understanding of how these plots are generated provides a base for other plotting modalities. And some of them we introduce as they are needed in the later chapters. So when we meet them, I will explain that to you. So here is just a simple example for you to show you. For example, we have a X variable, and which is from -2 to +2. And the middle one is the step of a variable. So which means this will, for each time we will increase 0.1. And the Y is just a transpose of the X. And Z is just a function which is X times E X minus Y squared. So E to the power -X squared minus Y squared. And when we apply the mesh function, it will create this 3D plot image. And this has no it doesn't mean anything for this. This is just a simple example to show you how it works. And here is another example to show you how it works. And for the FFT shift is function called the shift zero frequency component to center of spectrum. And the LP filter is computes the frequency domain low pass filter transfer functions. So you don't have to know how they works for now, but this is just an example. This means we will create a Gaussian distribution function. And after we use the mesh function here, and we plot every 10th point. And this is something we created by using the mesh function here. And for the WF, it means the wireframe. So wireframe, which are those lines? Wireframe means those lines in the mesh grid, you know. So that's something. Axis tight means just we plot the axis in tight mode. So as I mentioned, for now, you don't have to worry about those two functions. And so this is just to show you how the mesh function works and how to create some fancy image. So something else you want to say is that the view function. And for example, we can, so if you look at the previous slide, we have the axis in this one. You can turn off those axes if you want by using the axis off, and even the grid. You can turn off the grid by using grid off. And you can even change the view angle of the mesh plot. So here is the view, and those two numbers are the azimuth and the viewpoint of your view angle. So if you change those numbers, it will change the view angle of your 3D plot. And I'm not going to explain more details. You can try to play with this function after the class and see how that changes your view angle of your 3D plot. So the next one is the surf function. So sometimes it's desirable to plot a function as a surface instead of as a wireframe, right? So the function surf does this for us. So its basic syntax is just the surf function. And this function will create plots that are identical to mesh, except that the quadrilaterals in the mesh are filled with colors by default. This is called facet shading. And to convert the colors to gray, we use a function called a color map. So you can see that how the shading interp and color map affect our original image. And the axis and the grid and the view functions work the same as for mesh. You know, for example, the faceted shading can be smoothed by interpolation, and the mesh lines removed using function shading. So if you see, we have the lines in our image. But using the shading, you can just remove those lines if you don't need them, if you don't want them. And by using the interp option, so that's something for the surf. And for time reason, I'm not gonna give you more examples, but you can absolutely play with this function after the class. So the next thing I want to mention is I want to discuss how to write interactive functions that display information and instructions to the users. And so it will accept inputs from a keyboard or a mouse. And maybe you won't use this a lot in the future, but I just want to show you we have something like this in the Matlab. So we use display function in Matlab, you know, of course, to display information on the screen. And its syntax is very simple. And if the argument is a numerical value, for example, here we have an array, and the disp function will just display its contents just like in this way. And one advantage of using a character, so in the bottom side, you can see a character vector. For example, we have a vector called digital image processing using Matlab. And this function will just display it display the content of it. One advantage of using character vectors is that we can access their contents, just like we do for numerical vectors. And here is an input function. So for example, if we convert a character vector to a string using this function. And so the function input is to input data into a function using a keyboard. So this function outputs the words contained in the message. For example, if you type enter your data in your command window, it will just display enter your data. And it will wait for an input from the keyboard and followed by the enter key or the return key. And for example, if you type 25, it will save the value 25 in your in the variable you created, which is t in this function. So the input can be a single number, a character, row, vector, or you have to enclosed by single quotes, and a string enclosed by double quotes, and also a vector. You can enclosed by square brackets and or elements separated by the space or commas, or even a matrix or any other valid MATLAB data structures. You can input them by the input function. So the next is the mixture of characters and the numbers. So if the entries of a mixture of characters and the numbers, we can use one of MATLAB's string processing function, which is called text scan. So of particular interest in the present discussion is the function text scan, which has a syntax is the data and format specification. So here is a sample string which has three elements separated by the space. So by using the text scan, the first will be our data, and the second one is the format specific. And you see that we have %f, which means the float. And we have %s, because we think for the second and the third element, they're more likely the strings, right? So by this function, after you apply the text scan, you can display it as a cell. So the cell display. And you can see that if you just type C, you can see the output is just a 1×3 cell array. And the first one is a float, and the second and third is just a 1×1 cell. And the notation, if you look at the right side, the notation of the cell arrays. So the 3 to 1 is indicates the second component detected by the text scan function. And also similar for the 3-1. So if you type 3-1, it will return the content of that cell, which is stay, and similar for the X1. And this tells us that the state consists of a floating point number and 2 cell arrays, each with 1 component, right? So you may wonder, what if we just use one format specification? So in that case, for example, if you just use, for example, you want to convert everything to string, you can just use %s. And in this case, it will return. In this case, it will return a 1×1 cell array, which is a 3×1. So for the first one, it's the same thing, but this time they're just strings. What's the last one? The last one is stay. Okay, this is stay. So So what I want to say is that Matlab knew that the string had 3 separate components because of the blank space between between those 3 elements. And sometimes string components are delimited by characters such as commas. So we'll meet them, don't feel surprised. So the next one I want to mention is the input data by using a mouse is called G input. And this function will display a mouse-controlled crosshairs, superimposed on the current figure. So each click records the column, the row coordinates, which is in this array format, the C and R of the center of the crosshairs. So if you want to stop this G input, you just type enter, it will terminate the input. And usually the CR will be like X by, maybe it's K by 2. K by 2, I mean, is it will save so this will be a K by 2 matrix. It will save the column and the row information from the G input. So I think that's that's the last one I want to mention for today's lecture. So here is the summary. So after today's lecture, so I hope you know what is the digital image and how is the image coordinate different than the common space coordinates. And you want to know the different image types and how to convert between them. And also we discussed the plotting functions and the interactive input and output functions. So for those of you who know Matlab already, you may think these are some very simple examples, but this is just to help you, remind or review everything for the Matlab. And in our following lectures, you will use them a lot, and so make sure you understand how they works in the Matlab. And also, we will have more complex examples and in our following lectures. So I think that's for today's lecture. We're a little bit earlier, so you can for the rest of time, if you want to practice the sample code, you can try them in your Matlab. And if you have any questions, you can stay online. So I think I will stop here.
Thank you, Professor.
Yeah, no problem. And on our Thursday's lecture, we will finish the Matlab review. And so. Yeah, I'll see you on Thursday.
Professor, a question.
Yes, go ahead.
Professor, do we need means for homeworks? So we have to use MATLAB, or do we have any other option for the language?
I think for this class is the will. What do you mean other language
Python.
option? I mean, do you want to use like Python or
Yes.
C++? I think for this class we will just use Matlab.
Okay.
Mhm.
Right, cool. Thank you, Professor.
Yeah, no problem. So any other question? So if no question, I will end the lecture. I'll see you on Thursday. See you guys.